Hey guys, welcome back to my channel, and today we'll be starting off from where we left off, and that part is the position to term rule. So in our previous video we talked about a slightly similar topic called the term to term rule, and I recommend you to go through our channel and take a look at that video as well. So before I move on to the video, make sure to subscribe to our channel and smash that like button and share it with any one of your friends. So, less talking, more work. So, now I have two problems here, but before we move on to the problems, let's study what is the position to term rule. So, actually, the position to term rule means the general term or the nth term of a certain sequence. For an instance, sometimes you might have heard of a pattern called maybe 6n minus 3 nth term. So these are the types of nth patterns that you might see in your daily routines. So we'll be demonstrating you different types of creating these general terms. So let's get started. So first, let's give you guys an example. 3, 6, 9, 12. So if we take this pattern, and the nth term or the general term, there is a specific formula that we could use to find the nth term or the general term, and that is a plus a minus 1 times d. So now I'm going to tell you what is meant by a. So a means the first term, and d means the common difference. And in case if you don't know n means the rank of the term, like the first term, the second term, the third term, the fourth term. So we can sub that value in. So now, since we need to create the general term, we're not going to substitute any value. We're not going to substitute any single value for n. We're just going to keep it normal. But we're going to substitute values for a and d. So in this case, the first term is 3 plus n minus 1 inside brackets times d. So now we have all of this chunk of math, and now let's go through the common difference. So the common difference, if you observe it carefully, we can see that it's rapidly increasing by 3. So we can say the common difference is 3. Now using the distributive properties, we could easily determine that this can be simplified into a simpler expression as 3 plus 3n minus 3. And in this case, the negative and the positive cancel out. So as the final, you just remember 3n. And just like that, you have the general term as 3n. Let's bring it down here and let's put a box around it. And yeah, let's put a box around the formula too. So now we know that part. Now all of these parts were related to arithmetics. So since we talked about arithmetic here, now we're going to talk about geometry. So we talked about what is a geometric pattern, and if you don't know what is a geometric pattern, check out our previous video and you might get a really great idea about it. So now I'm going to put a geometric pattern right here. 3, 6, 12, 24. So in this case, finding the nth term or the general term is not going to be easy. It's actually going to be really difficult, to be honest. I have to admit. Because this is a type of pattern consisting of a really difficult formula to find the general term. And that formula is a r to the power ar to the power n minus 1. So let's put a box around that specific formula. Find the general term of this pattern using this. Oh, and in case you don't know what r means, so r is apparently a value equivalent to the meaning of the ratio. So you may be wondering how on earth is there a ratio in these patterns. So the ratio means how the value is multiplied with the previous term. So in this case, the value is multiplied by 2. So the ratio in this case is 2. So we're going to sub the values in. 3 times 2 3 times 2 to the power n minus 1 if n minus 1. So this would be the general term of our pattern. So let's put a box around it. So now we know how to find the general term of an arithmetic pattern or a geometric pattern. And here is a really simple note about how to solve it. And you can note this down if you want. And in the next video, we will be talking about finding consecutive numbers in a series. So we'll be seeing you in our next video. Until then, peace out.